we are going to look at type 2b problems, and this is the common ion effect, which, by the way, is a very common problem on AP exams and something you're going to use a lot in chemistry. So a very good one to know. Calculate the solubility of barium sulfate in 0.050 molar Na2SO4 solution. Compare this to the solubility of BaSO4 dissolved in distilled water. So I'm going to actually review the type 2 problem and just do the BaSO4 distilled in distilled water. If I take BaSO4 and I dissolve it in water, it breaks up into Ba plus 2 and SO4 minus 2. It's a 1-to-1 ratio. Your KSP expression would be Ba plus 2 concentration times SO4 minus 2 concentration. Because it's a 1-to-1 ratio, it's going to break up into equal moles of barium plus 2 and SO4 minus 2. So I'll call the barium plus 2x. Therefore, I'll call the SO4 minus 2x. And plugging this in, I got KSP equals x squared. If KSP is given as 1.5 times 10 to the negative 9th, it is x squared equals 1.5 times 10 to the negative 9th, or x equals the square root of 1.5 times 10 to the negative 9th, which is 3.9 times 10 to the negative 5th. So even though barium sulfate, we say it's generally insoluble, it still dissolves to a small extent. 3.9 times 10 to the negative 5th moles per liter, which is a really small amount. Now, what happens if I have this barium sulfate and I try to dissolve it instead of in water, a sodium sulfate solution? Well, sodium's not going to affect this, but if I have sulfate here, it would drive the equilibrium this way, making that solubility even less. So I'm going to expect a lower solubility because of this common ion effect. Okay, so let's take a look at how that would work. I'm going to maybe look at, I have the same KSP expression. KSP equals barium plus 2 times SO4 minus 2. What I'm going to do is just look at this reaction using an icebox. So you got a muscle strain or sore muscles, or you got swelling, or you have an equilibrium problem. When in doubt, ice it out. And we're going to go to the icebox right here just to get a guide for what to do here. So what happens is we have initially, this solution has 0 barium plus 2, but it does have 0.050 molar SO4. Notice if I were talking about sodium, it would be twice that amount because it's a 2-to-1 ratio, but we're not. It's 0.050 molar in our SO4 minus 2. So barium sulfate is not going to dissolve very much, and especially is not going to dissolve much if there's already sulfate there. But some of it still will dissolve because there's nothing here. So this does become X or plus X, and this does become plus X. So ultimately, 0 plus X is X. 0.050 plus X is going to be 0.050 plus X. So that's technically what we should put down here when we solve for this. But our assumption is going to be X is going to be real small compared to 0.05. So we're just going to use 0.050 and make the math a lot easier. Plugging that in, we know the KSP is 1.5 times 10 to the negative 9th. Ba plus 2 is X, and the SO4 minus 2 is 0.050 minus X, but we're ignoring, or I'm sorry, 0.050 plus X, but we're ignoring that addition to the 0.050 right there. Okay, so I end up having X is going to be equal 1.5 times 10 to the negative 9th over 0.050, and that equals 3.0 times 10 to the negative 8th. So notice my solubility is in barium sulfates in a 1-to-1 ratio with the barium. Okay, so this would not only be the concentration of the barium, it would also be the solubility of the barium sulfate. So this would be your answer right here. Notice it is what, 10 to the negative 5th, 10 to the negative 8th, 3 orders of magnitude difference, almost 1,000 times less soluble when the SO4 is right there in that system. Okay, let's just look at our assumption. What if I said 0.050 plus 0.0000003, it's still going to be 0.050. So notice our assumption is very accurate. There's no effect when we consider significant figures. All right, let's say you are a doctor and you are giving somebody maybe you wanted to take their digestive tract and take an x-ray. You might give them like a barium 131, allows you to see that and do that, but barium is also toxic. So if you give them this barium sulfate so you can see that, you're going to quick follow it up with like maybe a sodium sulfate milkshake, which will essentially drive the equilibrium this way, turn this barium ion, which is very harmful, into barium sulfate solid, which will cause the patient to eliminate the barium sulfate from their digestive tract through their solid waste disposal system. In other words, they'll poop it out. So that would be an application of this right here. So this is type 2B, common ion effect. There's another one to follow. Try that one. This is something we'll use very frequently. So make sure you're good with that. Thank you.